This is a review for multi-step equations. One thing that can happen is that you'll see x on both sides of the equal sign. You can't solve it until you address that, so you have to cancel one of them out. What does that look like? One option is to subtract x from both sides, canceling out the right. Another option is to subtract 2x from both sides, canceling out the left. Both of these are good moves, and they're both right. If you don't want to think about it, just pick one. Personally, I'm going to subtract the x, the reason being that after I do so, my negative is gone. Or I don't have a negative, I should say. When you complete this step, everything else carries down exactly where it is. Don't forget where your equal sign is. Notice my line. And on the right, x minus x just goes away. It's not 0x, so just x, something like that. It's canceled out completely. After this, I subtract 5. I start on the side that has the x that tells me what to deal with, and I do the opposite. Here's my answer. The other main type of question in this section is combining things that are on one side of the equal sign and then solving. So you can see here that x is on the left twice, and we can actually combine like terms. This becomes 4x plus 3 is 11. We undo these things in the reverse order of operations. So if you think about this being the order of operations, we start at the bottom. We undo the addition first. This gives us 4x is equal to 8. Then we're going to undo the multiplication. And we get x is equal to 2. So this one has both. I have an x on the left and the right, but there's something to combine as well. So I'll do my combining first. 5 and 7 can be combined, and this gives me this. And now I'm going to go ahead and cancel out one of the x's by subtracting it from both sides. What am I left with? 12 is equal to 2x plus 2, and now I'm at a two-step equation just like before. I undo this in the reverse order of operations. I divide here for the last step. 5 is equal to x. This time I have a similar problem, but I'm going to combine the x's instead of the numbers. And if I do that, 3x minus 3x, I actually cancel that part out completely. And the only thing left on that side of the equal sign is a 5. So after I have combined like terms, I'm back to a two-step equation where I can add 7 to both sides. 12 is equal to 2x, divide by 2. 6 is equal to x. No combining necessary here, but if I subtract x from both sides, I have 3 is equal to 5x minus 7, two-step equation. Plus 7 to both sides, 10 is equal to 5x, divide by 5. 2 is equal to x. Distribute first. 4x plus 12 minus 9 is equal to 27. The mistake that a lot of students make is at this point they do something like this. The problem is you have just subtracted from the left side of the equal sign twice, and that's wrong. You can't do that. It's going to give you the incorrect answer. Instead, before we start doing any of that, it's best to combine like terms. The 12 and the minus 9 can be put together, and you just get 3. And now when we start on the side with the x and we do minus 3, we do so once from each side of the equal sign. So I'm left with 4x is equal to 24. When I divide both sides by 4, I get x is equal to 6. A similar mistake that sometimes people make here is they put together all of the numbers, thinking 1 and 42 and 15, and put that over here somewhere. You can't do that. You can only combine like terms with the same side of the equal sign. So if this is my equal sign, you can only put together 1 and 42. So let's call that 3x plus 43. And on the right, I can only put together 7x and minus 2x, which give me 5x plus 15. So the first step is to combine like terms wherever I can. Now, I have one of those original multi-step equations where there's an x on both sides, and I can subtract 3x from both sides. I'm left with 2x plus 15 is equal to 43. If I subtract 15 from both sides, I have 28 is equal to 2x. If I divide both sides by 2, 14 is equal to x. Next problem, I have some combining like terms over here. And if I have 3x minus 17 is equal to negative 3x minus 5. Let's say I didn't avoid a negative and I subtracted 3x like this. I have negative 17 is equal to negative 6x minus 5. Then I'll add 5 to both sides, and I have negative 12 is equal to negative 6x. Last step here is to divide by whatever's in front of x. In this case, it's a negative 6, and I get 2 is equal to x. So it doesn't really matter which one you choose as your first step. I always recommend, after you distribute and combining like terms, to do the letters first. Last problem, I distribute the 2. This gives me 6b, 2 times 3, minus 8 is equal to 8b minus 11. I'm going to cancel out one of the b terms. Looks like 86, but that is 8b and 6b. Negative 8 is equal to 2b minus 11. I'm at a two-step equation. If I add 11 to both sides, I get 3 is equal to 2b. Don't panic, that doesn't mean it's wrong just because it's not an even number. You could write either 3 halves or 1.5 is equal to b. Last problem. If we add 9x to both sides, we now have 24x minus 10 is equal to 2. Then we can add 10 to both sides. And the most common mistake I see at this point is that people see 24 and they see 12 and they assume that the answer is going to be 2. So they take 24 divided by 12 and they get 2. The reason why that's wrong is you always have to divide by whatever's in front of x. So in this case, 12 over 24 can be reduced down to 1/2. And there's your answer. Not 2.